Hey gang, and welcome back to another exciting episode of Biology Online. And today we're going to be talking about chemistry. Now, this isn't a chemistry class, but in order to understand some of the things that happen in biology, we need to first explore some of the basic concepts that come from chemistry. So particularly when looking at the particles, ions, isotopes, and certain types of chemical bonds, how they apply to us and how they apply to biology all together. So we're going to start off. So here's a great little thing I like to start off this talk with, is this is a picture of basically an atom. You have things on the outside that are orbiting around. You've got things on the inside that are mostly staying still. Most of us know the electrons are on the outside, and in the center of the nucleus we have the protons and also neutrons. And one thing to think about is, remember that atoms are extremely small. So the particles that make up an atom are even smaller. So the electron that's orbiting around the outside is very small, even compared to a proton, which is in the center. A proton is like 1,000 times bigger than an electron, and electrons are moving extremely fast. I believe about 90% the speed of light, so about 270,000 kilometers per second, roughly about 175,000 miles per second, around a very small circle. You can imagine the amount of force that it takes for that proton to hold on to that electron as it zips around. And keeps it from zipping off and flying off and just flying away, essentially. There's a lot of different physics that's going on here in the center. So you've probably heard of gravity, and you've probably heard of electromagnetism, magnets. But there's two other main forces in the universe. There's the strong and the weak nuclear force. And essentially the strong nuclear force is what keeps the electron from flying away from the proton. Because it's going so fast, that proton has to hold on with an extreme amount of force, a lot of energy to keep that proton from leaving orbit. But also, in the center of an atom, don't you have a bunch of protons? At least in some atoms you have more than one. Protons are all positively charged. And we remember from science in grade school that same charges don't like each other, right? A positive and a positive push away from each other. If you have a magnet, a positive end will push away from another positive end. Likes attract, right? A negative and a positive will stick together, but positives push away from each other. So what's keeping all of those positively charged protons in the middle from pushing away from each other? Well, that's the weak nuclear force. There's a bunch of different physics principles that are going on here. So when we take a look at an atom, we're really looking at some basic physics and how that applies to the atom is going to affect, obviously, the things that atoms are made out of, like me and you. We're all made out of atoms. So let's start off by just naming the parts of the atom. Let's talk about the different atomic particles. So on the side we have proton, neutron, electron, orbital shell, nucleus, and we also want to label the charge. So let's put them on our graph. Well, at the top, up here, you'd probably think, okay, well, those are probably electrons, and you'd be right. And what charge are they? They're negatively charged, right? And then there's these different concentric circles. What do you think these represent? That's right, these are the orbital shells. This is the orbits around the center that the electrons can be found in. So we call those the orbital shells. There's more than one, so you can add another line, make that look like there's two orbitals. And here in the center, we'll start off with protons are found in the center, and they are positively charged. These other ones, these red ones, will be what else is found in the center other than protons? Good, neutrons. Neutrons are found in the center, and they don't have a charge. They are neutrally charged. Altogether, the center of the atom is called the nucleus. So if you were to fill it out, this is what you have. Electrons are negative, orbital shells, protons that are positive, neutrons, which are neutrals. That's just an equal sign with a slash drawn through it, showing that it has no charge. And then the center is called the nucleus. That's the basic anatomy of an atom. So now that we know a little about the anatomy, let's start putting some terms with it. Let's start looking at some of the different ways that we will represent these. So the first one's going to be the atomic number. We use this number to kind of represent the element. So the atomic number is the number of protons that is in the nucleus. When you see it written on a periodic table of elements, generally speaking, the atomic number is usually found at the top, maybe the top corner, and this little square is found at the top. You also have the symbol for the element. The element name is usually written out, and then also the atomic weight. The atomic weight is the number of protons plus neutrons. Hydrogen doesn't really have any neutrons for the most part. some of its isotopes it can. We'll cover isotopes later. But hydrogen, for the most part, is just it's just one proton, one electron. So, but when we say that the atomic numbers, the number of protons in the nucleus, why is that even important? Well, the number of protons is what defines an element. The number of protons is what gives that element the properties that that element has. You cannot forcibly change the number of protons in an element, except in stars, because that's where elements are made. Hydrogen forced together become helium. Helium and another hydrogen are forced together to form lithium. Two heliums become beryllium, and so forth and so on up the periodic table. Only till about the 26th element, which is iron, and then after that, iron production kills the star. The star explodes. The heat and pressure release from the explosion creates every other element on the periodic table in one big blast. So, what do you mean we can't change the number of protons in a nucleus? Well, we'll give you an example. Back in the 12th century, one of the earliest branches of chemistry started called alchemy. And alchemists were trying to convert lead into gold. They were not successful at it because you cannot forcibly change the number of protons. It cannot be done. You can't change one element into something else. So it's just the way things work. So when we say that the number of protons defines the nucleus, the atomic number defines the nucleus, we really mean that there's a big difference between having one proton and having two protons. For example, this is an example of hydrogen. Two things you can learn from this picture. First of all, the hydrogen is flammable. Also, it's lighter than most air. It's a pretty light substance because they put it in the Hindenburg. But hydrogen is extremely flammable, right? Let's go up one, let's add one proton to it. One proton and one electron. Then we have helium. Helium, first of all, it's non-flammable, but it's still lighter than the air that's in our atmosphere. So we can use it to fill up our balloons. Imagine having a kid's birthday party with the flames from the candles on the cake mixed with hydrogen gas balloons. That would be a disaster waiting to happen, right? So having the helium is a lot safer, but helium also does something different. You can breathe it in, and when you exhale it, it makes your voice sound like a higher pitch. And the reason why is your vocal cords work because they vibrate as air passes by them, and the vibration rate is defined by how big the air molecules are as they pass by. Most air that we have is oxygen, nitrogen, carbon dioxide, and there's some helium, there's probably some hydrogen in there too, but very, very small amounts. But when you have mostly helium, or take a big breath of helium, helium's a lot smaller than oxygen and carbon dioxide. And so it hits the vocal cords more frequently, which causes it to vibrate at a faster rate, which causes a higher pitch. So that's why helium, we can breathe in helium. You don't want to do it though for long, because you can actually go into a coma, because if you're breathing helium, you're not getting oxygen. You couldn't do that with hydrogen. You could once or twice and you'd probably die, because hydrogen has some special properties to it, because it only has one proton, that it loses its electron pretty easily, and we call things like that acid. So hydrogen gas is actually pretty corrosive. You take one breath of that and your alveoli are going to start falling apart and you're going to suffocate and die. So that's what we mean by the number of protons gives an element its specific characteristics and the specific qualities that it has.